Hello everyone. So we are going to walk through last year's test, and I have two different versions of it, so I'm going to switch back and forth. So you're going to see on the packet that you have that sometimes I'm just skipping from one to the next, but you have them both in the packet I gave you. Alright, our first graph, f of x, here is a piecewise function, so we have a piece of a parabola, then we have a linear equation here, and then we have another linear, which is a constant little segment, and then another linear going up. So piecewise functions with four different pieces. Our concern here is mainly the characteristics of this function. So I want the domain of f of x, and the domain, remember, would start from the point the most to the left to the point most to the right. In the left, right there, we have a closed dot, so my graph stops there and doesn't keep going on the left-hand side. On the right, however, I have an arrow, meaning my graph is going to keep going up and out to the right. So the domain, the point most to the left will be right here. There is nothing that passes this point, and that will be an x. Remember, for domain, we go x values. And so it will be from -6 all the way to, well, since it doesn't stop, it's going to keep going out as it goes up, so it's going to keep going toward, oh, sorry, that should be not negative, but positive infinity. So it goes from -6 to infinity. Infinity, we never have a bracket, it's always a parenthesis because it's a direction, not a specific point. At -6, however, I have a closed dot, so the domain really includes -6, so I need a bracket right there. How about the range? Range will be from the lowest point to the highest, so again I have a lower limit because this is the lowest point I have on my graph, and so that will be from the y values this time, because range will be y values, and the lowest y I have is -4, and it goes from -4 all the way to infinity because it's going to keep going up. And a parenthesis for the infinity and a bracket for -4 because it is definitely part of my graph. We want to find the x-intercepts. So x-intercepts are the zeros wherever the graph crosses the x-axis. And I'm only crossing one here. There are graphs that are have more than one, but this in particular has only one x-intercept, and that will be at -4. You need to specify what you're talking about, so you need to put an x equals here on -4. So I'm going to go to the other graph I have here. So I need you to look at this graph, and this graph also is a piecewise function. And if I wanted the domain of this graph, I have an arrow on that side, then I'm going to follow my function. I stop here, but I restart here at the same x value, so I'm going to keep following. Stop, stop, attention, attention. Those are both open. I would have to exclude this x value from the domain because there is no point here, there is no point there. So x equals 2 is not part of that function. So for my domain here, I will start from -infinity, and I will keep going. So you say, well, why are we not excluding this one? Because this is open, but this one is definitely closed. So -1 has a y value of -2, so it is included in our domain. But 2 doesn't have any y value assigned to it, so we have to take it out. So 2, not including, and then we start again from 2, but not including it. And then we're going to keep following the graph, and we stop here with a closed dot, so we stop at 7, including 7. For the range, so the lowest y to the highest y. Well, there is no lowest one because this graph is going to keep going down, so I'm going to go down to -infinity, parentheses. And then, if I look at all my y's as I move up, all of those values are accounted for, right? They all have a point somewhere all the way to 9. But 9 is a circle open, so there is no point on the graph for the y of 9. So close that. Alright, back to this one. oh no, I wanted to say one more thing on this one. X-Intercept. So the X-Intercept here, notice how I would cross the X twice. I do not cross here because this is an open circle, and therefore I do not have an X-Intercept here, but I have one at -5 and I had one at -2. So my X-Intercept would be where f of 0, that's f of 0, right? Where, no, sorry, that's, oh goodness, I lost it. X-Intercept, there they are. X-Intercept, -5, -2, and again, label, so x is equal to -5 and -2. Alright, back to this one. Find the y-intercept. So the y-intercept is where we cross the y-axis, so it's right there at 2, and again label, so y is equal to 2. Where is f increasing? So we're going to read from left to right, and we want to know where is that graph going up. So from left to right, if I start on the left, up, right, this graph is going up, and it's going to keep going up, all the way to here. At x equals 2, the graph is not going up anymore, it is now constant. And then it starts going up again here at 4, where it goes up and up again. So where is my graph increasing? It starts increasing at -6, and it's increasing all the way to x equals 2, stop there, and again at 4 all the way to infinity, because after that the graph is going to keep going up as shown by this arrow. Where is my graph decreasing? Well, up, and here constant, right? So sorry, not go this way only. If my graph is constant or increasing, it never decreases, so we're going to say never. Constant will be that little segment right there, so from x equals 2 to x equals 4, so from 2 to 4, the graph is constant. Where is f of x positive? So remember that f of x stands for y, so we want to know where is y greater than 0, meaning where is the graph above the x-axis. So the graph is going to be above the x-axis from my x-intercept here on, right? Everything else here is going to be above the x-axis, so the only place I'm not will be that little chunk there. So starting at x equals -4, so from -4, and then we said to infinity because it's going to keep going up and up. Oh, sorry, yes, right, positive. At -4, do I want a bracket or a parenthesis? Well, let's look. At -4, the y value here is 0, and 0 is not greater than 0, it's equal to, so we are not going to include -4, because -4 is not positive, it's actually 0, which is neutral, it doesn't have a sign. Where is f of x negative? That would be where are the y less than 0. So now I want to know where is my graph below the x-axis, and the graph is going to be below the x-axis from -6 all the way to 4. So from -6 all the way to 4. At 4 we are at 0, we are not less than 0, so not including 4. But at -6 my y value is definitely a negative y value, right? It's -4, so I want to include that. Alright, and behaviors. And behaviors are the behaviors as you go to infinity. Either positive or negative. So as you go to the left or to the right of the graph, right? So you're not concerned about what's happening in the middle, you want to know as you go to the infinities. So as x goes to positive infinity, that means to the right, what does f of x do? F of x stands for y, so what are my y value approaching? Remember that arrow in math means approaching. So as x goes to the right, so as I'm moving to the right, what are my y values doing? They're going up to infinity, right? So that would be up to infinity. And when you do the other side, as x goes to negative infinity, what are my y values doing? So as I'm going to negative infinity, trouble, we are not going to negative infinity, right? Our domain stops at negative 6. We are never going to negative infinity here. So we would say none. There is no end behavior on the left. Alright, so let's look at that. Here it's a translation. So we're given the parent function f of x equals x squared, and we need to translate it like that. So we need to graph this g function according to the translation for the parent function x squared. Remember, we said inside with the x, it's opposite of what you think, and that's left or right translations, right? So if it's a plus, you're going to the left, and if it's a minus, you're going to the right. So because we have a plus, we're going to the left by 1 unit. So from here, that vertex is going to move left by 1. And I'm there now, but not finished. This one here on the outside tells you up or down, and on the outside what you see is what you get. So negative goes down, positive goes up, and because we have a minus 3, we know we go down 3. So we went to the left one, and now we're going down 3. So to the left one and down 3. The vertex is going to be right here. There is no negative in the front, so no reflection. So it's just going to be this graph like that. And that's your G graph. Here they're giving you a graph, and you have to match which equations goes with that. So the parent function of an absolute value would look like this. And so we need to know what happened. So my vertex has been moved up by 3, so I'm looking for a plus 3 on the outside. All of those would work, so A is out. And then I moved up 3, and then I moved to the right by 1. To the right would be inside, and inside it's opposite of what you think. So to the right means I need to look for a minus 1 inside. So those two would work. This one is out, this one is out, because both of those will be moving to the left instead. So the other thing I need is my absolute value has not just been moved up and right, it also has been reflected. So I need a negative in the front, and this one doesn't have one, this one does, so this is my answer. Alright, keep going with translations of function. If you have a parent function h of x, that's the square root of x, and you're going from this to this one, you need to describe what happened, right? So in that box, we're going to describe. So from my parent function, I have a minus 2, and remember inside it's opposite of what you think, so minus means you go to the right 2. So that's what you mean by describe. So you go right 2 units, and then the plus 5 is on the outside, so plus outside what you see is what you get. So you're going to go up 5, so up 5 units. And then we have a number in the very front here, and those are your vertical stretch or compression. Since the number is greater than 1, this is a stretch. So we have a vertical, make sure you write that vertical stretch there, by a factor, and here we have to say by how much do we stretch it, right? So it's a vertical stretch by a factor of 3, because that's the number we have. So that's what we mean by describing the translations, transformations. Alright, we're going to skip what's above here. We're going to go straight to this one. Does the table given represent a function? So if it is a function, every x can only have one y value. So is there any x that repeats? No. So is this a function? Yes. Find find the inverse of the following relation. So here I'm given x's and y's, right? Those are x and y's, and I need to find the inverse. And if you recall, when we did the inverse, when we had an equation, we switched x and y to find the inverse. So that's exactly what you're going to do here. To find the inverse will just be those switched. So instead of having negative 3, 9, my inverse is going to have 9, negative 3. And here it's going to have 1, negative 1. Well, the 0, 0 is not changing, right? Because 0 is neutral, doesn't have a sign. Then here I'm going to have, instead of 2, 4, the inverse is going to have 4, 2. And I'm going to have 9, 3. All of those points will be on my inverse function. So just switch x and y. We are given a graph, G, and its function right there, and we need to give the domain. So the domain of this graph, here we don't see that, but that's going to keep going. It's been hole punched here, that little arrow. The domain of G will be, if it keeps going down and out left and down and out right, all my x-axis will eventually have a y value assigned to it. So the domain here will be from negative infinity to infinity, all of them. The range, I'm coming from the negative infinity, right? All those y values will be assigned because it's going to keep going down, so negative infinity. But I have a highest point here. It's not passing 3, so 3 will be my maximum. And 3 is part of my graph because there is no bubble there, so I need a bracket. Is this a function? So can I do the vertical line test? Function means vertical line test. Every x has only one y assigned to it. And so yes, this is a function. Is it a one-to-one? Now one-to-one means it has to pass the vertical line test and the horizontal line test. So vertical, we said it passes. Does it pass the horizontal? It doesn't, because when you're sweeping through with a horizontal line, you're going to touch at two different spots. So no, this is not a one-to-one. From the parent function of an absolute value, we need to describe the translation. So the parent function of an absolute value will be right there. And so what has happened to it? Well, the negative one inside is left or right, and because it's inside, it's opposite of what you think. So we go to the right by 1. So right 1 unit. Plus 3 is outside. Outside, what you see is what you get. So it goes up 3 units. And then we have a negative in the very front here, and those are your reflections over the x-axis. So we're reflected over the x-axis. Okay, let's do some composition of function down here. So we're given two functions, f of x and g of x, and we're going to have to find f of g of x. So remember, we're taking the inside out. So you're going to take the inside is g. So this function is going to go in f wherever we have an x. So f of g of x becomes this. But wherever we had x, we're going to replace this x with the g function, right? The inside becomes the g, so 3x squared. Now we simplify, so we're going to distribute that. 2 times 3 is 6, so 6x squared, and then the plus 1 in the back. That will be your composition. Alright, now what if I have a value? Then I can just plug in the 1 and we still move backwards. So plug in a 1 into f first. So go to f and find f of 1. So if you plug in a 1 for your x's, that will be negative 1 plus 3, which is equal to 2. Now I'm going to, so all of that here becomes a 2. Now I'm going to take that 2 and plug it into G. So take your 2 and plug it into G. So I need G of 2, and that will equal to 2 times 2 plus 1, and 2 times 2 is 4 plus 1 is 5. So the final answer here will be 5. I need to find the inverse of f of x. So remember, for inverses we switch that f notation here, function notation, to y. We switch x and y, so that becomes x. And now I solve for the new y. So remember, we do plus or minuses first. So that's a plus 1. I'm going to move it across by make it a minus 1. So it's gone here now. So I'm left with negative 5y. And because those are tied by multiplication, I'm going to divide both sides by a negative 5. And so my answer here will be x minus 1 over negative 5. Normally we don't leave a negative in the denominator, so I'm going to change everybody's sign and make that a negative x plus 1 over positive 5. But any of those two answers will be correct, and that will be the inverse.